Hi guys, welcome back to my YouTube channel. This is Tanushree. In this video, I have taken the topic that is some of the basic concepts of chemistry. So we have to move on through the top topics of the chemistry. So we have to know some basic concept of the chemistry. Okay, in this video, I'm going to tell you the basic concepts of chemistry, what it involves. Okay, firstly, I'm going to explain the importance and the scope of the chemistry. So what was the specialization it has? Okay, and then laws of chemical combinations. Okay, in that we are studying the four laws. Okay, law of conservation of mass, law of definite or a constant proportions, and law of multiple proportions, law of what we can say multiple reciprocal proportions. Then we have to know about the Dalton's atomic theory, and after that atomic and molecular masses. So these are all topic involved in this video. So please do watch at the end till at the end. Okay. So do subscribe to my YouTube channel and click on the bell button icon that will notify you for my upcoming videos. So let's move on to the. So firstly, we have to know the some importance and the scope of the chemistry, right? So what was the chemistry? So first we have to know about the chemistry. Chemistry, it is a science of chemical elements and compounds, and it is the study of the materials that make up our bodies and everything around us. So chemistry, it is a science stream subject. In that it will involve the chemical elements and compounds, which are some of them are man-made compounds, some of them are naturally occurring compounds, and it is the study of the materials that make up our bodies, like some of the chemical components in our body in with around of us. On to this some loss of chemical combinations. Okay, so for we have the loss of chemical combinations. First one is law of conservation of mass, law of definite or a constant proportions, law of multiple proportions, and law of reciprocal proportions. Okay, these are our four laws which under the chemical combination, laws of chemical combination. So go through the one by one. Here first one is law of conservation of mass. So the law was first established by French chemist Lavoisier. Okay, Lavoisier. This law states that in all chemical changes, the total mass of the system remains constant. What does it mean? So here it is nothing but when there is a chemical change in a any molecule, between any molecule, I had taken the example here H2O, right? In that we are having hydrogen and oxygen. So these elements having their different masses, right? If we do any chemical changes on these two molecules, what happens? Then the reactant which having the mass of sum of mass of these molecules, so there is no change in the mass, so mass will remains constant. So mass can neither be created nor be destroyed. Okay, in a very chemical changes, so any chemical reactions or any chemical changes, the mass of the each molecule after the product, it will remains as same. Okay, mass will be remains as constant. This is what the law of conservation of mass says about. Okay, next we'll move on to the law of definite or a constant proportions. Okay, this law was proposed by Prost. Okay, uh, it's very difficult to pronounce their name, so we have to know with their name with a good spelling also. It's very important because it may ask it in the competitive exams or wherever. Okay, it's very basic topic. Okay, so what it states, elements always combine in a fixed ratio of their weights, or a pure chemicals compound contains the same elements in the fixed proportion of their weights, regardless the mode of preparation. According to the law of definite or a constant proportion, here what does it means elements always combine in a fixed ratio. Here I taken the example same H2O here. Here what was the element mass here? It is 1, right? And what was the, sorry, atomic number is 1, and oxygen atomic number is what? It is 8, right? So here the 1 is to 8 proportion. Okay, like that the elements always combine in a fixed ratio. So these two elements having their equal or not equal, okay, they having their own ratio. Okay, their weight will be in fixed. Okay, Understanding? A pure chemicals compound contain the same element in a fixed proportion. Okay. The elements which containing their own mass or own atomic number with their ratio, there will be fixed in the product. Okay, so this is what the law of definite or a constant proportion says. There is no variations in their ratio before the reaction and after the reaction. Okay, next we will move on to the third law, that is law of multiple proportion. Okay, this law was established by Dalton. Okay, what it states whenever the same two elements from form once again, whenever the same two elements form more than one compound, the different masses of a one element that combine with the same mass of the other element are in the ratio of small whole numbers. Here, the two elements, okay, same two elements. Here, I taken the carbon monoxide and carbon dioxide as an example here. You can see here what happens. The elements of a same compound, right? CO, it's from carbon monoxide, CO of from carbon dioxide. So same two elements from more than one or two compounds, okay, one or two compounds having the different masses, right? Carbon and oxygen has a different masses, okay, according to their atomic number and weight, okay. And what happens that combine with the same masses of other element, okay, when the oxygen combines with the carbon with their mass only, okay, it will combines with the another mass of the carbon element, okay, in the ratio of a small whole number. That is nothing but in their ratio, okay, in their own ratio it will forms, right? Here one carbon atom and one oxygen atom which reacted to form the carbon monoxide. Here what happens, one carbon atom, okay, 12 gram of carbon and 32 gram of oxygen here. Okay, 16 gram, right? 16 gram of one oxygen, 16 gram of another oxygen. It will form carbon dioxide, CO2. Okay, one carbon, two oxygen, carbon dioxide. So whenever the same two elements of a one or more compounds that different masses of a one element, right, that combines with the same mass of a other element are in the ratio of a small whole number. Okay, this is what the statement of the law of multiple proportions with a good example. Next, we will move on to the law of reciprocal proportions. So this law was given by Richard. Okay, the law states that the ratio of the masses of a two elements A and B, which combine separately with a fixed mass of a third element C, okay, is either the same or some simple multiple of proportions of the masses which A and B combine directly with each other. Once again, you have to concentrate on the statement, okay. The ratio of a masses of a two elements A and B which combine separately with a fixed mass of third element C, this either the same or some simple multiple of proportions of the masses which A and B combine directly with each other. Here what does the statement means, so the ratio of the mass of a two elements. Here consider element A, carbon be the element A and sulfur be the element B. So having their own masses. Carbon has a 12 gram and sulfur has a 64 grams, okay, which combine separately with a fixed mass of third element oxygen with their mass 32 gram. Okay, both are same. Okay, both are same here. Third element is same. So then what happens? These two elements which combine to the oxygen, third element of a C, then forming a multiple proportions. And there will be a fourth element, okay, in the upcoming reaction. There will be a fourth element that will having the same mass. Okay, here consider. Okay, here's carbon, sulfur, sulfur oxygen is there. So next we will take what we can take another oxygen atom. Okay, just we take oxygen atom. Here what happens? The element A and element B have their own masses, right? Here 64, you have to correct it. Okay, have their own masses. Then the third element of again oxygen. Okay, the third element of oxygen or some other elements can you take. Okay, the third element of this element having their own mass 32 gram. Then what happens? These two uh, these two elements which combine with this oxygen, yes, combine with O2, what happens? Yes, O2 again one reaction. Then O2 reacts with O, then what happens? O3, ozone layer. Okay, like that the reaction multiples from AB to AC, BC, then AC to AD, CD, like that the reaction will be multiples. Okay, that's what you're saying. The ratio of masses of a two elements A and B which combine separately with a fixed mass of third element C. So those two elements which combine with the third element of a fixed mass, that is oxygen. Okay, either the same or some simple multiple of proportions, either the same or some upcoming proportions, multiple proportions of the masses which A B combined directly with each other. So they will combine with that third element with each other. So this is what the law of reciprocal proportions says. So next we will move on to the Dalton's atomic theory. Okay, a new system of a chemical philosophy. Here he established a new system of a chemical proportions in 1808. Okay, he in which he proposed that matter consists of a definite particles called atoms, and all atoms of a one particular element are identical. That is nothing but atom of element may not be necessarily possess some same mass, but possesses same atomic number and shows the similar chemical properties, identical properties. Okay, here atoms of a different elements have a different masses. That is nothing but atoms of a different elements have may possess the same masses, but they always have a different atomic numbers and differ in their chemical properties. So this is what the difference in their chemical elements have the different masses. When bound together in a different way, atoms from the compound in a definite ratio by atoms. Next, atoms can neither be created nor be destroyed. So atoms of a one element can be transmuted into atoms of a other element. Okay, and then there are a number of compounds which do not follow the law of constant proportions. Such compounds are called as the non-stereometric compounds. So that is what the Daltons made the new system of a chemical philosophy for the atoms and molecules. Okay, next we will move on to the atomic and molecular masses. In that we came to know some definitions of the atomic mass, gram atomic mass unit. So these are all definitions which involves in this atomic and molecular masses. So first we came to know the atomic mass. What was the atomic mass? So this is atomic mass of an element. It is a number and which includes as how many times an atom of the element is heavier on an average as compared to the 1/12 of mass of atom of a carbon 12. Here what was the atomic mass of the element? So element having their own masses, right? So how much is it heavier? Okay, how many times the element is heavier, that too going to be compared with the 1/12 of mass of the carbon. Okay, then we will get the atomic mass of that element. Since the atomic mass is a ratio, it has no unit, however it is expressed in AMU or U. AMU, it is nothing but atomic mass unit. U, it is nothing but unified mass. Okay, here one atomic mass unit is equal to 1/12 of mass of a carbon 12 atom. So what was the carbon mass is 12 gram, right? So divided by Avogadro number, we have to put the Avogadro number. So we will get the mass of the one atomic mass unit. Okay, then we will move to the gram atomic mass. So it is a mass in a grams of a 1 mole of atoms in a monatomic element. It is numerically equal to the atomic mass in an atomic mass unit. So this is a mass in a grams. Okay. Here the 1 mole of atoms in a monoatomic element, that is nothing but hydrogen. So what was the moles of hydrogen we are adding to the reaction? So number of moles of atom of a monoatomic element, that is nothing but which the element which cannot be combined with the other element, so it will be single, so that is nothing but monoatomic element. Okay, it is numerically equal to the atomic mass of that. So number of grams atoms or a mole atoms. Okay, number of grams of atoms is equal to mass of that element in a grams to the gram atomic mass. What was the gram atomic mass here? The 1 mole of atoms of the monoatomic element, okay, which is equal to the atomic mass in atomic mass unit. So what was the atomic mass unit defined? Okay, one atomic mass unit is defined as mass exactly equal to 1/12 the mass of a one carbon 12 atom. So atomic mass unit is equal to, or atomic mass of an element, which is equal to mass of a one atom of an element to the one atomic mass unit. So the atomic mass of unit which is of an element which is equal to what? So mass of the one atom. Okay, one atom of that element. Okay, which is with respect to the one atomic mass unit. So this is what we came to know, the atomic masses in that gram atomic mass and atomic mass unit. Okay. Next we will move on to the molecular mass. The molecular mass of a substance, also called as molecular weight. It is obtained by multiplying the atomic mass of each element by the number of its atoms and then adding them together. So here molecular mass, it is also known as molecular weight. Okay, mass weight is almost similar words. Then how to get the molecular mass of an each atom in the element? So multiplying the atomic mass of the each element. Okay, multiplying the atomic mass of an each element by the number of its atom. Okay, by the number of its atom, the elements which contains atom. So then the number of its atoms and then adding them together. So multiplying the atomic mass of an each element and the number of its atom both get added, then we will get the molecular mass. Okay, so gram molecular mass. So the gram molecular mass of a substance expressed in a grams. Okay, its name itself says it is expressed in the grams and it is called its gram molecular mass. Okay, which is expressed in a gram, then it is called as a gram molecular mass. Okay, molecular mass. Example, molecular mass of the calcium carbonate. Okay, that is 100 U. U, it is nothing but unified, what we can say, unified mass. Okay, then gram molecular of a calcium carbonate is 100. So this is what the example for the gram molecular mass and the molecular mass. So a number of a gram molecules or a mole molecules is equal to what? Mass of a substance in the gram to the gram molecular mass. Okay, then the mass of a substance in a grams is equal to what? So number of the grams of molecules into the gram molecular mass. Okay, so formula mass, molecular mass having the another one, that is formula mass. Okay, the smallest unit of an ionic compound is a formula unit. The mass of this formula unit is called as a formula mass. This is what the atomic and the molecular mass involves, these important basic knowledge for a chemistry. Okay, so next we will move on to the mole concept. What was the mole concept? So what it defines? A mole, it is defined as the number of atoms in a 12 gram of carbon. Okay, the number of atoms in a 12 gram of carbon has been found experimentally to be 6.02 into 10 to the power 23. That is Avogadro number. Okay, this number is known as the Avogadro number, as I told you. So what does the mole defines? So it is the number of atoms. Okay, the number of atoms which is found in experimental reaction or chemical reaction. Okay, then it will with it to the Avogadro's number. So this is what the mole defines. A mass of a 1 mole atoms. Generally, we can say that mole means what? If wherever there is a chemical reaction, so we have to know the how much of mole how much moles of element we are adding. So how much moles of a molecule we are adding to give a reaction. So that is what the mole concept involves. The mass of a 1 mole atoms of any element is exactly equal to the atomic mass in a grams of that element. So mass of the 1 mole of atom of any element you have considered, okay, is exactly equal to what? The atomic mass in a grams of that element. Okay. So 1 mole of any substance will have mass equal to formula mass of that substance expressed in the grams. So as I told you, formula mass, it is the smallest unit of that ionic compound. Okay, it is a formula unit. Okay, so the mass of this unit is called as what? Formula mass, as I told you in the molecular masses, right? So 1 mole of any substance will have it will have mass, right? So mole of any substance which have their own mass, okay, that is equal to what? The formula mass. That is nothing but formula unit. Okay, formula unit, and the substance is expressed in the grams. Number of moles of a substance is equal to what? So how to calculate the number of moles of a substance? That is mass of the substance in the gram to the mass of 1 mole of the substance in the gram. Then mass of one atom of the element, which can be given as gram atom of an element to their Avogadro number. Okay. So mass of a one molecule of an substance, which can be given as gram molecular mass of the substance to the Avogadro number. So this is what the mole concept involves. So it is very important basic topic, so we have to know. Next we will move on to the percentage composition of an element. So percentage composition of element is the relative mass of each of the constituent element in the 100 parts of it, and it can be calculated if we know the molecular mass of compound. Okay, suppose the molecular mass of a compound be m and x be the mass of the element. So molecular mass of the compound be the m and x be the what? Mass of the element in the molecule. So how we calculate the percentage of that element? That is molecular mass of the element. Okay, molecular mass of the element. Molecular mass, it is nothing but what? That is the substance which obtained by multiplying the atomic mass of element by the number of its atom and then adding them together. So we will get the molecular mass to that molecular mass of the compound, okay, into 100. We are calculating the percentage, so we have to multiply with the 100. Okay, x by m into 100. This is what the percentage. This is what the calculation of the percentage composition of that element. So I hope this video is helpful for you. So thank you for watching this video. Please like, share and comment on this video. Thank you.